Hey, what's going on, everybody? Today is the day we're finally going to talk about it, and that is VRRP on an edge router. Now, this is one of those more advanced topics. It's also almost completely pointless to use in at least a home network setting, but this is one of those protocols that really makes large and enterprise networks highly redundant and resilient. So we're going to take a look at how to actually get this going, maybe in your home, or if you have a small business environment with edge routers, then this could definitely be something you want to use. Now, if you're not familiar with VRRP or you have no idea what it is, don't worry, I'm going to explain the dry theory of it and what it is, how it works, why you would want to use it. So for those of you who know about VRRP and just want to know how to configure it on an edge router, you can go ahead and skip to that section. There should be timestamps in the description below. However, there will be a few kind of caveats and pros and cons to doing it on an edge router here in the actual explanation. So if you're used to VRRP, at least on like Cisco equipment or some other vendor, you might want to stick around for the explanation because the edge router doesn't really support everything that you would normally want to do with VRRP, but for the most part, it's there. All right, so let's go into the explanation here. So first off, what in the world is VRRP? Well, what it stands for is Virtual Router Redundancy Protocol. And basically what it does is almost creates like a virtual router, or at least a virtual IP address that you can use for redundancy. Now, if that is as clear as mud, let's take a look at a diagram and how a regular network would function and is configured. So typically what you would have is something like this. You got your internet connected to your router connected to a client. Your router is going to have a public IP on one end, which is going to the internet. And it's going to have its private or LAN IPs on the other side. So something like 192.168.0.whatever, and we'll say that the router is 0.1. So then your host would have an IP like 192.168.0.10 or something like that. Now, when your client gets DHCP, there's three parts to that, and that's their IP address, which is right here. This is the IP address that they'll get. The subnet mask, which we'll just say in this case is a /24 or 255.255.255.0, and they get a default gateway, which is going to be the router's IP address. Now, say that this router goes down. There's a power outage, it goes corrupt, something happens, we no longer have that router. Well, our client is just SOL. They have a default gateway for 192.168.0.1. They try to contact it, it is dead. It will no longer work for them. So let's say we want to add another router to the mix and kind of try to prevent against this. So we add another router, we connect it up to the internet, we either have two different connections to two different ISPs, or two to the same, or two connections to a switch that's connected to the internet. We'll get more into that and kind of why it doesn't make sense in a home environment later, but for now we'll say we've got two internet connections and now we have two routers set up. So when we set up our routers, we've got to have our WAN IPs and we've also got to have our LAN IP. So let's say we're going to put this on the same network, 192.168.0. And since one is already taken by the other router, we're going to have to give it an IP of .2. And just so this makes a little bit more practical sense, kind of running out of room here, but let's just say that these are both connected to a switch, just a dumb switch, and that is what is actually connected to our client. And then the switch has a connection to both of these routers. So this is awesome. We've got redundancy, right? If one router goes down, we can just use the other one. Well, yes, we can, kind of, except for the default gateway situation. So right now, our clients are set to use 192.168.0.1 as a default gateway, but if that router dies, sure, we have another route out to the internet. We still have connectivity. There's a router that's still alive. There's a connection that's still alive, but our clients aren't going to use that because they're set to the default gateway for the router that is now dead. So what we would have to do is go into our DHCP settings and update them to point to our new default gateway in order to fail everything over. Now there's got to be a better way to do this, and that's where VRRP comes into play. So what VRRP is going to do is it's going to create a virtual IP address. We'll say 192.168.0.254 just to kind of differentiate it. and it's also going to have a virtual MAC address associated with it. Now, these two routers are going to share that IP and MAC between each other. One of them is going to be designated as the primary, and the other is going to be designated as the secondary or backup. And whichever one is the primary is going to own this virtual IP address. Traffic will still go to the other router, but it's going to drop all of it because it's not active for the virtual IP. So everything is going to be going through our primary. Now, if for some reason we lose our primary router, then our virtual IP just gets taken over by our secondary router, and the secondary becomes the primary. And there is very little interruption in traffic because all it takes is just VRRP to fail over and our secondary to become the primary, take over that virtual IP address, and our default gateway still works. So that, in a nutshell, is VRRP, why you would use it, and just kind of a little bit how it works. Now, there's a lot of nuts and bolts to VRRP, and I'm going to go ahead and hit just a couple of the basic terminology, I guess. So to configure VRRP, you've got to have what's called a VRRP group, and that's just basically an arbitrary number, but it needs to match on all of the routers. So say we have a group of 2, that is going to be our, in HSRP it's called a standby group. I forget the actual name of it in VRRP, but if we assign group 2 to both routers, then they're going to form a VRRP relationship between each other, and that's going to be what determines the virtual IP, who's the primary, who's the secondary, whatever. You can actually have more than 2 routers in this. So you could have another router over here, also a part of group 2 for additional redundancy, but we're just going to keep it to 2 for the purposes of this video. And every time you do a VRRP configuration, you're going to specify what group you're applying the configuration to. You can have more than one group on an interface, but I'm going to back off of that concept for now. Now the second term is going to be preempt or preemption. And what this means is, will the primary take back over after it comes back online? So by default, VRRP will not preempt itself. So if we lose our primary router, our virtual IP is going to be taken over by our secondary. It now becomes the primary. But say our primary comes back online. By default, our secondary router is going to stay the primary, and our old primary will now become the secondary, and that's how it will stay until this one fails and it goes back to the primary. Now say we don't want that to happen. Say that our secondary router does not have all the complete configurations of our primary, and it's really just there to keep the internet connection up. We don't really want to run on it all the time. Maybe it's a cheaper device, doesn't have the throughput of the primary. We want the primary to always be the primary device when it is available. That's where preemption comes into play. So if we have preemption enabled, we lose our primary router, it fails over to our secondary. Once it comes back online, our group is going to know that, and it's going to fail back. Our secondary will again be the secondary, and our primary will become primary again. Now our third term is going to be priority, and this is a very big term. This is basically how VRRP decides who's primary, who's secondary, who's active, who's not. And the priority is pretty much a value between 1 and 255, I believe. I'm actually not 100% sure if that is the range, but basically the higher the priority number, the higher priority that router has. So if our primary is priority 200 and our secondary is 150, that is what designates this one as the primary because its priority is higher. Now, one thing that I don't believe the Edgerouter has the capability to do, in a Cisco environment, you would have what's called a decrement, and that would track some other sort of like IPSLA object. Say it's pinging google.com, that ping fails. That would kick in a decrement, and it would take a certain value away from the priority. So say that track object comes into play, it goes down. It'll take 50 away from the primary, so its priority, while that statement's true, would be 150 instead of 200. And say we set the secondary at 175. As long as Google's pingable, our primary will have a priority of 200, but as soon as it isn't, it goes 150. That is below 175, so our secondary will become the primary. Now, as far as I know, this is not a thing that you can do on the Edgerouter, so that's one major difference that I have found in my very limited exposure to VRRP on the Edgerouter. And basically what that means is for us to fail over to the secondary, we would need a total device failure or an interface outage. And by an interface outage, I mean the cable goes bad or something happens to where that interface is showing down on the router. Without the interface showing down, VRRP thinks that everything is good, everything's up. But if you've ever been in the situation where, say, there's an ISP issue, your connection between the router and your ISP is going to be just fine. You're going to be able to ping your ISP gateway. It's awesome, but your ISP has a problem. You can't get to Google, so effectively the internet is down. This is not something that's going to be tracked by VRRP on the Edgerouter. You will need to either manually fail it over or have a total device failure. But this is still good, in my opinion, at least like for my home. If I need to do a firmware upgrade on my router, but I don't want to interrupt an internet connection, I can go ahead and apply a firmware update to my primary router. It can reboot, do its thing, and it's not going to matter because everything's going to fail over to the secondary. Once it's back up, preemption, it'll fail back over to the primary, and then we can run the firmware upgrade on this one. So that's really, at least in my eyes, the main benefit here to running it in a smaller environment, especially without the added benefit of IPSLA and actual tracking objects. Now, the Edgerouter running on Linux, there is definitely ways around this. You can kind of set up a rudimentary or custom tracking ability. I have seen on the internet where you can, you basically create a load balancing group, and that effectively takes over the IPSLA function, and then you can kind of mess with the priority from there. But that is beyond the scope of what I'm doing in this video, and I haven't actually tried that yet. And also kind of going along with that custom stuff, there is what's called transition scripts on the Edgerouter, which basically means that if your VRRP group or instance goes between one of the three different modes, the master, standby, or fault, then you can specify a custom script to run whenever that happens. Again, not something I've tried, not something I'm going to get into here. Now, the final terminology I'm going to go over here is just authentication. If you've ever messed with like OSPF authentication or anything like that, it's pretty much the same thing. You assign the group some sort of key, like a pre-shared key, and then routers are not going to be able to join the group without having the correct authentication key. And this is more for enterprise environments where you might be worried about somebody hijacking the network infrastructure. If you have VRRP enabled and no authentication, technically somebody can just bring in a router with VRRP configured with the right group number, the right IP and all that, and get all the traffic to go through theirs, which you may or may not want. Now, this shouldn't be an issue in your home or business, at least a small business, because you're probably going to notice somebody coming in and hooking up a second or third router into your network. Hopefully you've got some oversight into that. But in a big enterprise environment where you're dealing with thousands upon thousands, hundreds of thousands of endpoints, hundreds of devices, very large networks, this can be a problem. And if somebody were to put a router in there and connect into your VRRP instance, they could wreak complete havoc in a heartbeat. But that's really all that means. So at this point, let's take a look at what we're going to do with our actual configuration. That is pretty much the basics of VRRP and how it's working here. Now, I did say I would hit on some of the caveats with the dual ISP situation. What I mean by that is there are situations where VRRP is almost a moot point because most home networks don't have two connections to the ISP. Usually you only have one, and that usually goes to like a modem or something. So the big issue here and why it's not that big of a advantage in a home environment is because of single points of failure. And what I mean by that is your ISP probably goes to a single modem, then you got your two routers running VRRP down here, but if your modem goes out, VRRP does nothing. That's the single point of failure. Also, you got your two routers, you have your single switch connected to your client, your switch goes down, VRRP doesn't matter, that's a single point of failure. Same thing with the client, client's NIC goes bad, boom, it's also a single point of failure. So VRRP is only really going to protect you if your routers have an issue. and it's very isolated to that. If you wanted to take full advantage of VRRP, and this is what they do in the enterprise environment, you would have actual two different ISPs, say like AT&T and Verizon, both with connections to the router. You would have a tiered architecture here where the routers have connections to two different switches, which have connections to themselves. And if you were really running a high redundancy environment, you'd have two NICs in the client connected to two different switches. So if at any point these fail, boom, you still have a path. Boom, you still have a path. This NIC dies, that path still stands. So VRRP complements tiered architectures very well, but it's not as useful when you have multiple single points of failure, but still something cool to do. That's why we're going to do it today. So here is just the outline of my actual network. This is what we're actually going to be dealing with today. I've got one connection to an ISP going to a modem, so I'll have my WAN IP here. My modem is 10.88.254.1. Both of my edge routers, one of them is going to be 254.2, the other is 254.3. And then my LAN is 10.88.13.0. Primary edge router is going to have 13.13 and the secondary 13.12. That's a little bit backwards, but whatever. And these are connected to a single switch, which is connected to my desktop. And as you can see, I do have the multiple single points of failure. This is probably what most people's home network, at least that want to run VRRP, will look like. So if my ISP modem dies, I'm out of luck. If there's an ISP issue, I'm out of luck. If this switch dies, I'm out of luck. Like there's so many places that this can fail. But if all we want to do is have our internet connection up when doing firmware upgrades or something like that, then this is going to work just fine. So what we're going to do is we're going to configure a virtual IP and a VRRP group between our two edge routers. I'm going to give it an IP address of .254, and we're going to set that in Dhcp as our default gateway. And then we're going to run some tests, unplugging some cables, rebooting devices, etc., and see how it performs. And specifically the devices I'm using, primary is going to be an Edgerouter 4 and the other is going to be an Edgerouter-X SFP. So in my situation, my backup device is going to technically be slower and it's not going to have all the configurations on it. I do have port forward rules coming in, so I'm hosting some servers off of the main router somewhere over here. Those rules are all going to go away when we fail over, and if we really wanted to, we could set up the SFP to actually fully take over, and we could also do two different VRRP groups, one for the inside and one for the outside. That way our port forward rules and DMZ and all that will still function, but again, I'm not going to get into that, at least in this video. Maybe we can save that for another time, doing VRRP with hosted services. Alright, so let's go ahead and jump into the verification and configuration of this. First, we're going to make sure that our secondary Edgerouter-X SFP can actually connect to the internet. So I'm going to open up my IP address properties and put in my 10.88.13.88 address. At least I think that's what my address was. And my default gateway I'm going to change to .12, and I'm just going to use DNS public Google, or Google public DNS. And let's see if we get an internet connection here. And it doesn't look like we do. So let's log into the Edge router and see what is going on here. So it looks like we've got our internet address, 10.88.254.3. I do believe that is correct. And we're connected to the router, so that's good. Our virtual tunnel does not matter at all. Let's go ahead and look at the routing table. It doesn't look like we have a default route. Oh! We actually don't have a default route, and I'll tell you why. I'm going to go ahead and disable that VPN route. That's not necessary. It's because I don't have DHCP running on the internet side, so it's not grabbing a gateway. This is manually configured, so we don't have that next hop gateway for default route. Now we can either put in a static route for default gateway, or we can just make the actual system gateway address what we need it to be, which is 10.88.254.1, and we'll go ahead and save this, and we should get an address. I guess I have to uncheck UNMS because that's throwing an error for me. Now since we have a system gateway, we should be able to browse to somewhere. Let's try to go to waveform.com. We're still getting nothing. What about YouTube? Nope, nothing. So let's go back in here, take a look at our routes. We do have default route to 10.88.254.1. I'm going to go ahead and log into my other edge router and just verify that's the correct address. All right, and we appear to have internet connectivity through this second edge router. Let's go to google.com. Yep, we can search for things. There we go. The issue ended up being a route to another network that I have, which takes care of DNS. Because this edge router only has the route for my modem and this 13 network, it couldn't reach the DNS server, and that was pretty much the issue. So let's go ahead and configure Vrrp since we know that it's working. And to do that, we are going to connect to it with PuTTY. Log into it, UBNT, I still have the default set on this one. Now what we're going to do is enter configure mode, and we'll do a show interfaces just to see what we're working with here. And yep, we've got our 254.3 address on the WAN side, and we should have, yep, our switch interface 13.12. We are good, so we're going to apply Vrrp to our switch 0 interface. And to do that, we're going to do set interfaces switch 0, and then Vrrp. And if we do a question mark, well, we only get Vrrp group, so we have to assign it a group number. I'm just going to call it group 1. And if we do another question mark, we can see all of our options here. Now, we already talked about things like authentication, preempt, priority, and a little bit about virtual address. We haven't really touched on preempt delay or any of these other options, but we're going to go ahead and assign it a virtual address. So Vrrp group 1, virtual address, and this is going to be what we want our default gateway IP to be. So 10.88.13.254 is going to be our new one. And if we do a question mark, there's no other configurations that can be done here. So we'll go ahead and click enter and get that command back, Vrrp group 1. Now we are going to configure the priority. And since this is going to be our secondary device, there we go, 1 through 255 is the priorities that we can assign it. I'm going to give it a priority of 150, and I plan to give the primary a priority of 200, so this will keep it the secondary. Go ahead and click enter, and then get our command group 1 back here, and we're going to enable preempt. So we're just going to do group 1, preempt, true. So this means that if our primary comes up with a higher priority, then it's automatically going to fail us over to that one. And that's pretty much all we have to specify for Vrrp to be configured. And really, we don't even have to go that far. All we really need to do is define a virtual address for this Vrrp group, and it'll start working. However, there's a few defaults that are assumed, like there's a default priority that it'll pick. Preempt will be disabled by default. So these other commands, while they're not entirely required, you want to configure them. And another command that's kind of like that is the preempt delay. I like to put that on mine. So Vrrp group 1, preempt delay, and if we do a question mark, you can see we specify how many seconds we want it to delay. I'm going to do 120 seconds, so 2 minutes. And what this does is when the primary comes back online and the Vrrp group sees that it's back online with the higher priority, since preempt is enabled, it's supposed to just take back over. However, if we configure this delay, once it sees it up, it's going to wait this amount of time before actually swapping over. And this is something good because once Vrrp sees that the primary is back active and good, that router might not have built all of its tables. It might not be fully able to forward traffic if there's a lot of stuff it's got to do in the meantime, like if there's a bunch of VPN tunnels that haven't established yet, if OSPF is running and it hasn't established neighborships yet. You don't want it just instantly flipping over to the other router because it might not be ready for the traffic yet. So by configuring this delay, you're giving that router the opportunity to get everything that it needs to forward traffic in place before you actually start sending everything its way. So at this point, let's go ahead and do a commit. And if we exit out of there and do a show Vrrp summary, then you can see what we configured on switch 0. We got Vrrp group 1. It's a virtual IP, 10.88.13.254. The interface state is up and the Vrrp state is master. Now it is saying that it is the master because there is not another one configured right now. And I actually just realized that I am using 13.254, so I can't really use that address. We're going to make a slight change here. We're going to change that to 13.252 instead of 254. Alright, and I'm kind of an idiot. I was trying to change the VRRP address on Ethernet 1, which we did not configure. We put it on switch 0, so switch 0, VRRP group 1, virtual address 10.88.13.252. Do a commit, show configuration commands, looking for VRRP, and just as I thought, we have 2 virtual addresses now, so let's go ahead and do the delete interfaces, switch 0, VRRP group 1, virtual address 10.88.13.254. Do another commit, and we're good. So I should probably check and make sure that IPs aren't used by something else before I start doing videos, but we're good now. So we'll go ahead and exit. I'm not going to save the changes yet, but if we do show VRRP summary, there we go, our virtual IP has changed, and we'll do a show VRRP interface as well. Oh, yeah, interface switch 0, just to see what we got here. It gives us a little more information, but just kind of in a different order. And at this point, we should be good to configure our other router. So let's open another instance of PuTTY, SSH2, the router that's going to be our primary. And for this one, our actual interface that we're going to configure is, I think, going to be Ethernet 1. Need to actually check here. Yeah, Ethernet 1 has our 88.13 address on it, so we're good. Let's go ahead, enter configure mode, set interfaces. Here we're going to do Ethernet ETH1, VRRP group 1, and we'll just go ahead and do virtual address 10.88.13.252. Now, if we go ahead and do a commit at this point, we should get VRRP to talk. So if we do run show VRRP summary, you can see we are actually in the backup state. And let's do interface ETH1, see what other information we have here. It does say we're in the backup state, but our master router is unknown. So maybe we just haven't had long enough to actually transition, but let's go ahead and look back on our other router and see if we have anything else here. And it looks like we don't, so we'll go ahead and go back here. And we can kind of see the defaults here. Well, I say kind of see, we can see the defaults here. We're still showing unknown. But anyway, since all we did was configure the virtual IP, we have this virtual IP address of 13.252, but you can see the other defaults, which is the priority is 1 by default, so pretty much at the very bottom of the priority list. Yeah, we have no authentication. Preempt apparently is true by default here on the Edgerouter. I did not know that. On Cisco devices, I believe that Preempt is turned off by default, so that's a difference. I'm still not really sure why it doesn't know where the master router is. I don't know for sure if they're actually talking, but one way we can find out is if we bring back up those commands for interfaces and just kind of do the rest. If we set group 1 a priority of 200 and commit that, then we should transition states here. So we'll go ahead and exit out of there, show VRRP summary, and yep, you can see we are now the master. Let's go ahead and show interface ETH1 now. And it is showing us as the master router. Our priority is now 200. And if we go back to the previous router and run that same command, you can see we have transitioned to a state of backup. So they are actually talking, but since the other router now has a priority higher than this one, it has taken the role of master. And it still shows master router unknown. Not entirely sure why it's not giving us any info there, but apparently it's working just fine. Since preempt is true already by default, I'm not going to configure that over here, but I am going to put the preempt delay here. So preempt delay of 120 seconds. With this on, it's not going to swap over immediately. And I'm just going to look and see if there's any commands that I missed here. See, we got preempt delay. We don't need preempt because it's already true. Priority is already set. Virtual address is good. That's all we need. VRRP is good to go. So at this point, what we would do is update our DHCP settings to use this .252 address instead of 13.13. Now, one note here, if you're running VRRP between these two routers, you really want DHCP somewhere other than your edge router. You probably want a standalone DHCP server somewhere, because we don't really have a way to sync DHCP between two edge routers. What we would have to do is come up with a split scope, and that's not always ideal. So just to be on the safe side, don't run DHCP on your edge routers if you're going to be running VRRP, unless you just really need to and want to deal with the extra complexities that causes. Now, I am running DHCP on my edge routers, but I'm not going to actually update it. I'm just going to flip my connection here to use that address instead. So basically I am, 252, not 254. Basically I'm just going to simulate getting that address by DHCP. Now let's see what we can do. All right, we've gone to Google and it looks like we can still search. And if we go to our address bar and we try to do HTTPS 10.88, messed that up, 10.88.13.252, it's going to take us to a web page. Now, depending on which router is primary at the time is which router this address is going to take you to. So you're pretty much dealing with 3 IP addresses now. You've got 13.13, which is the actual IP of the primary, 13.12, the actual IP of the secondary, and 13.252, which is the virtual IP, and that'll flip between the two at will. So if I go ahead and log in here, you can see, yep, we are in the primary one. It is the Edgerouter 4. So what we're going to do here is I'm going to bring up a command prompt. I'm going to bring up a command prompt, and I'm going to start a ping to google.com. Do a -t, and we're just going to restart this edge router and see what happens here. So restart the device. Yes, I'm sure it's in the process of being rebooted. If we minimize, we are still pinging Google. It doesn't look like we've even dropped a single one. Now, I know on Cisco devices, when you initiate a reboot or an admin reset of an interface, it immediately fails over VRRP, and it looks like that's probably what's happening here. It's a little bit different than an actual outage. When an interface just goes down, VRRP has to wait until its hello timer expires, but when you do a reload, usually it just immediately fails over. So if we do HTTPS 10.88.13.252, we get a page and we're going to log in. I'm going to try UBNT, which should be the credentials for the secondary, and yep, boom, there we go. We browsed to the same IP address and got a different router. And we didn't even drop a packet while rebooting that one. Now let's give it just a little bit, because once Edgerouter 4 comes back online, it should be 2 minutes before we fail back over. So we should see the graph or something time out here in this web page, and we'll see if we drop any more pings when it fails back. And I'm just gonna start opening different pages, just kind of like, you know, I'm going about my business in here, just looking at settings. I'll just go ahead and open speedtest.net as well. We'll see if that does anything when it fails over. Well, it's definitely giving us a higher latency here. But if we go back, let's refresh this page. Maybe we've already failed over and I just don't know it. Nope, we are still on the backup. So it's definitely been about 2 minutes, I think. And I'm still in here. If I do a refresh, we're still on the backup router. However, I am noticing that the internet is not putting very much through. So I think what we're running into here is just a stale session, since we're connected to this router already on that IP. I think that we've just got a session established and it's not actually kicking us out. So I'm going to go ahead, get out of there. I'm going to bring our SSH back up and do a show VRRP summary, and it actually looks like we are still the master. So let's go back to the other side and see what's going on over here. So show VRRP summary on this side, oh wow. Okay, so it definitely helps to save your configuration before you reboot the router. So just 1 second here. All right, so let's put those commands back in and actually save them this time. So commit and save, exit out of there, show VRRP summary. We are now back to the backup, and if we look at our pings over here, we still didn't drop one. So let's go ahead and try this test again. Refresh the page here. Try to go to 10.88.13.252. Okay, and we're still on the SFP router. And if we bring up our Edgerouter 4 on a show VRRP interface, you can see we've only been up for 1 minute and 3 seconds. So since I just committed all of these at the same time, it's going to wait the 2 minutes before it actually swaps back over. So right now we're at 1:28. Let's just bring this up and see what happens once the 2 minute mark rolls around. Okay, and I still haven't noticed any pings dropping. I've only noticed a few of them being a little bit higher on the latency than normal. But if we do our show VRRP interface, we look like, yep, we're 41 seconds over that 2 minute mark, and we are the master again. Didn't drop any pings. Gonna go ahead and make sure that I'm saved. We did get a timeout on this session, so now we are back on the regular one. So let's do this one more time just to be safe. We've already seen that it works. I'm just an idiot and forgot to change the configurations. So also this time I'm going to start a speed test right before I restart this device. So once this kicks off, I'm just going to hit restart and we should be good. So let's restart. Yep, yes, I'm sure it's in the process of being rebooted. Oh, we're actually getting we got 2 pings that said destination net unreachable. However, our speed test did not even flinch. And if we go to 13.252, we should be getting the SFP. Yep, Edgerouter-X SFP. And we are now in. So let's just go ahead and start the timer for about 2 minutes and we should be getting kicked out of here again. Now there are some kind of inconsistencies, I guess. Not inconsistencies, we'll say some quirks to do with this. You can see that my interface is kind of weird. All of them say connected, but the addresses are to be determined, and there's not really any bar graph info or anything at all. This kind of comes from it being the same IP address, but keeps flip-flopping between different certificates and different endpoints. You'll get some of these weird issues that just kind of come from it flipping back and forth. I think the computer gets confused sometimes on what's actually going on behind the scenes. Most of the time, if you close the browser or open another incognito window or something, it'll kind of clear that up. And I just saw that we dropped 2 pings over here, so we might have already failed back over. So let's just refresh this and see what we got. We're still on the SFP though. I'll go ahead and kick another speed test off. That might have just been a fluke. We are speed testing just fine. Let me just close that out and go back to 252. Nope, we're still on the SFP, it seems. I'm just going to keep kicking off speed tests until we fail back over. It's always good when you can't really tell when it fails over. That means it's working good. But we're also doing this in a reboot scenario, which causes immediate failover. It's not waiting for those hello packets. And it looks like we're having trouble loading, so I think we did fail back over. My browser is just doesn't know what to do with itself. Alright, so I opened a new window, 10.88.13.252. Well, it took us back into the SFP, but now it says the session's timed out and it's asking us to log in again, so go ahead and log back in and we're back on the Edgerouter 4. So that worked. After 2 minutes, we failed right back over. I did not see us drop a ping. Maybe the latency got a little higher, but it wasn't even noticeable. So that's pretty much everything you need to know to get started with VRRP on an Edgerouter. Hopefully you learned a thing or two. This isn't just applicable to an Edgerouter, it's just one of those more advanced features that is nice that the Edgerouter actually supports, even though if you're doing this at home, it is going to have limited use cases pretty much, but we've already talked about that. As always, if there's any questions on this, leave them in the comments down below. And as always, happy networking.